an object from interstellar space has been observed to visit our solar system.
Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
Astrophysicist Neil Degrasse Tyson has finally addressed the mystery surrounding Oumuamua. This space object zoomed through our solar system at a shocking 3 times the speed of the average comet. Named after the Hawaiian term for messenger from afar, Oumuamua has confused astronomers with its unique features. Positioned at a distance of 15 million miles from Earth, its unusual speed goes against the principles of space mechanics. So join us as we navigate the universe to uncover who is behind Oumuamua, the red mystery from interstellar space. In 2017, something big happened in astronomy. Scientists spotted an object called Oumuamua. This find was a major deal because Oumuamua was the first object from outside our solar system that we ever saw passing through. This discovery was a remarkable moment in scientific exploration, creating waves in the world of astronomy. Before Oumuamua, astronomers mainly focused on studying things within our solar system. But even with that focus, there were still many things they didn't fully understand. Oumuamua changed that by opening up a whole new area of exploration, giving researchers a rare chance to study a celestial body that came from beyond our solar boundaries. Oumuamua showing up wasn't just a random event. It allowed scientists to peek into areas they couldn't study directly before. Picture the joy among scientists who usually explore the things we know in our solar system. Suddenly, a mysterious guest from interstellar space showed up. Calling this discovery groundbreaking is an understatement. Exploring Oumuamua was important for a few reasons. First, it gave scientists a rare opportunity to look into the diversity and composition of objects from faraway star systems. This chance helped unlock deeper insights into the basic building blocks and formation processes that control celestial bodies all across the universe. Scientists went on a mission to figure out where Oumuamua came from, what it went through during its trip through space, and how it ended up looking the way it did. And guess what? The things they found out were pretty mind-blowing. They did a bunch of studies and put together a puzzle of information about what Oumuamua is made of and what makes it unique. It's not just about this one space object. It's like finding a gold mine of knowledge that gives us a sneak peek into the stuff happening in faraway space. Each piece of info they got from studying Oumuamua was like a clue, helping us understand more about how things work for celestial bodies cruising through the huge stretches of space. Unlike the usual asteroids or comets we spot in our solar system, Oumuamua looks more like a long rock, kind of like a cigar. It's quite different from comets, which mainly come from the outer parts of our solar system, like the Kuiper Belt or the Oort cloud. These icy comets usually have a mix of frozen gases, water ice, dust, and rocky stuff. Now, Oumuamua's stretched-out shape is not the norm for comets. They usually come in more rounded or uneven shapes, like lumpy snowballs with all sorts of bumps and dips. When comets get close to the sun, the ice inside them starts turning into gas, letting out dust particles. This whole process often creates a cloud of gas and dust around the core, sometimes forming a tail that points away from the sun because of the solar wind and radiation pressure. So, Oumuamua is a bit of a cosmic oddball with its unique shape compared to the more familiar comets we know. Comet sizes can be really different, like from a few hundred meters to several kilometers. Take Halley's Comet, for example. It's this well-known visitor to our solar system, and its nucleus is thought to be about 15 kilometers wide. Some comets have even bigger nuclei, like tens of kilometers or more, but they usually have a similar shape. Now, Oumuamua is a bit of an oddball. It stands out not just because it's a visitor from outer space, but also because it's got this unique reddish color. This color is similar to stuff we find in the far-out parts of our solar system, suggesting it's made of something special. What's interesting is that Oumuamua didn't have the usual comet features when it swung by the sun. Most comets have this cloud of gas and dust around their nucleus called a coma, but Oumuamua didn't have that. This absence of a coma tells us that Oumuamua isn't your typical comet. It's something completely different, as we are about to reveal. Oumuamua's unusual behavior under solar pressure. Oumuamua's got scientists scratching their heads because it's doing something quite unusual. It's speeding up, and it's not just because of the sun's gravity. There are two main reasons behind this strange behavior: outgassing and solar radiation pressure. Outgassing is like when a comet gets all heated up by the sun, and the stuff trapped inside it, like gases and ice, turns into vapor and shoots out into space. This process creates a glowing cloud around the comet's core and gives it that famous tail you see in pictures. Well, Oumuamua seems to be doing a similar thing, suggesting it has some volatile stuff inside it, much like comets. Now, solar radiation pressure is another player in this cosmic drama. It happens because sunlight carries tiny particles called photons, and when these hit an object in space, they transfer a bit of their momentum to it. For Oumuamua, this solar pressure could be influencing its movements, making it deviate from the path we'd expect based only on gravity. Even though each tiny particle of light, or photon, doesn't carry much push on its own, when you add up all the countless photons from sunlight, it creates a pretty significant force. Now, Oumuamua is not your average space rock. Its shape and the constant bombardment of photons from the sun might be teaming up to make it move in a way that's not just about gravity. Think of it like this: the sun's light is like a steady stream of tiny pushes, and because Oumuamua is kind of stretched out, it's catching those pushes in a way that might be nudging it along. It's like a dance between Oumuamua's shape and the never-ending flow of sunlight, causing it to go off its expected path. So, it turns out, there's more to Oumuamua's journey than just the pull of gravity. Oumuamua is quite the cosmic acrobat, spinning around like a top. What's intriguing is that it goes from extremely bright to not so bright, with a whopping 10-fold difference in brightness. It takes about 7.3 hours for it to complete one spin, and this flashy light show it puts on is way more intense than any asteroid or comet we know of in our solar system. Now, figuring out how big Oumuamua is turns into a bit of a puzzle. Different studies and observations have come up with different guesses, making it tricky to pin down its actual size. NASA's smart folks at the Jet Propulsion Laboratory took a crack at it and suggested that Oumuamua might have a spherical diameter ranging from a minimum of 320 feet to a maximum of 1,440 feet. So, picture a ball within that size range, and you've got an idea of Oumuamua's potential shape. On the flip side, NASA's solar system exploration has a different take on Oumuamua's size, suggesting it might be a whopping quarter-mile long, making it potentially 10 times longer than it is wide. This hints at a major stretch along its main axis, giving it a pretty elongated shape compared to its width. But wait, a recent study throws a curveball into the mix, proposing a smaller size for Oumuamua. According to this study, we're looking at dimensions of about 146 by 144 by 24 feet, way smaller than what was thought before. Yet, despite these differing opinions, one thing stays constant. Oumuamua is still rocking that cigar-shaped appearance, making it a mystery that needs some serious investigation. Enter the PanStars One Telescope, stationed up near the top of Haleakala on Maui, Hawaii. This telescope, with its 1.8-meter diameter, is a big deal in the Panoramic Survey Telescope and Rapid Response System project. It's a collaboration between the University of Hawaii Institute for Astronomy, MIT Lincoln Laboratory, Maui High Performance Computing Center, and Science Applications International Corporation. The PanStars project is all about keeping an eye on the sky, using cameras, scopes, and a fancy computing setup. It not only spots moving or changing celestial things, but also gives us detailed info on stuff we already know about. But is the PanStars One Telescope the key to unlocking the secrets behind Oumuamua? Insights from PanStars One's primo location. Since kicking off full-time observations in May 2010, the PanStars One Telescope has been really helpful, even snagging the important job of spotting Oumuamua. The PanStars One Telescope is like a detective gadget, perfect for studying objects like Oumuamua. What makes it stand out is its special wide-field design that lets it check out a big chunk of the sky at once. This makes it more likely to spot faint celestial objects that might go unnoticed. With a big 7 square degrees field of view and a huge 1.4 gigapixel camera, these features help it gather tons of data and make it accurate at finding and tracking celestial bodies, even the dim ones. Now, the PanStars One Telescope is sitting in Hawaii, and that's a big plus. The island gives it awesome advantages for studying things like Oumuamua. The skies there are very clear and dark, with minimal light pollution, creating the perfect conditions for observations. The combo of the telescope's keen eye for faint stuff and Hawaii's primo location played a crucial role in spotting Oumuamua as it cruised through our solar system. Oumuamua's journey is like a space mystery. It came into our solar system from the direction of the Lyra constellation, but where it came from exactly is still a puzzle. It could have been drifting through the galaxy for billions of years before making its way through our solar system. A recent study in the respected journal Nature Astronomy presented a fascinating idea about where Oumuamua, the interstellar object, came from. The research suggests that Oumuamua likely broke off from a larger planet in a different solar system. The gravitational forces from its host star then caused immense pressure, breaking it into pieces. These pieces were scattered into space, starting Oumuamua's journey after being expelled from its original solar system. One intriguing aspect of Oumuamua's behavior in our solar system is its unexpected acceleration. It suddenly sped up, deviating slightly from its expected path. Initially, Oumuamua entered our solar system from above the planet's orbital plane, passing very close to the Sun at 0.25 astronomical units. After this close encounter, it continued its trajectory, exiting below the planetary plane. Throughout its journey in our solar system, Oumuamua maintained a high velocity, moving at an impressive speed of about 196,000 miles per hour. This rapid speed indicates the significant kinetic energy Oumuamua had during its journey. The composition and structure of Oumuamua might contribute to this speed, as studies have unveiled interesting details. This interstellar visitor has a strong outer layer made of carbon-rich materials, hardened by cosmic radiation during its long journey through interstellar space. On the flip side, the inside of Oumuamua is dense, mainly made up of rock and possibly containing metallic elements. Importantly, it doesn't have water or ice, making it stand out from the usual comets or icy bodies seen in our solar system. Additionally, the surface of Oumuamua has a reddish tint, a result of enduring long-term exposure to cosmic rays over hundreds of millions of years. This extended interaction with cosmic radiation has permanently changed Oumuamua's outer appearance, setting it apart from other celestial bodies of similar types. Is it possible that Oumuamua is more than just a natural space object, but rather an alien spaceship or tool sent for exploration? Well, let's hear from scientists. The alien hypothesis. Jennifer Bergner, a chemist at the University of California, Berkeley, and her colleague Daryl Seligman, an astronomer at Cornell University, were part of a team that studied Oumuamua. They're saying this because Oumuamua doesn't look like other space things. It's shaped like a long cigar, not round or bumpy like usual. This weird shape is different from what we're used to seeing in space. Also, Oumuamua doesn't move like it should based on gravity, making some people think it might be using advanced alien technology, like a light sail powered by star energy, to move around. They're wondering if Oumuamua could be a part of a fancy alien spaceship or tool sent on purpose to explore faraway star systems. What's even stranger is that Oumuamua doesn't have the usual tail or gas stuff that usually comes with comets or asteroids, which adds to the mystery. Some people think the aliens are trying to hide by not using the usual stuff we look for. This idea also suggests that the aliens might have a secret way of moving through space that we don't know about yet. The strange, reddish color on Oumuamua's surface adds another twist to the guessing game. Renowned physicist Neil Degrasse Tyson thinks that the color might be on purpose, chosen by possible alien creators. According to him, they might have used special materials that react with space radiation, creating this unique hue. This deliberate coloring could be a way for Oumuamua to blend in with red celestial bodies in outer star systems, perhaps as a form of camouflage to avoid drawing too much attention. Now, here's the speculative part. Imagine an advanced alien civilization in a distant star system. They have super advanced technology, allowing them to explore space and study other civilizations. They spot Earth and notice signs of life, sparking a keen interest in our planet and its diverse life forms. The big mystery then becomes, why would an alien-made object want to hide while traveling through space and visiting other solar systems? Curious about Earth, the advanced alien civilization decides to send a reconnaissance mission for information gathering. In this narrative, Oumuamua takes center stage as a peculiar celestial object that could be viewed as a vessel crafted by these extraterrestrial beings. Its distinctive shape and materials might be specifically designed for safe interstellar travel. The elongated form likely serves to minimize the impact of cosmic debris, ensuring stability during its extensive journey through the vastness of space. Oumuamua's uniqueness goes beyond its shape. It's also about how it moves. It appears to possess an advanced method of traversing space, enabling it to cover great distances and navigate with precision. This sophisticated mode of travel allows Oumuamua to explore different areas freely and avoid obstacles in its path. Equipped with advanced tools, sensors, and communication devices, Oumuamua is like a high-tech explorer on a cosmic mission. Oumuamua's primary role appears to involve collecting covert information about Earth, including details about our atmosphere, ground, and any signs of intelligent life. Once it gathers this information, it transmits it back to its creators, enabling them to study our planet from a considerable distance. The peculiar actions of Oumuamua, such as initially approaching Earth and then abruptly changing direction, could be woven into a narrative. Perhaps it completed its data-gathering mission and departed from our solar system. While the sudden change in direction raises questions, it aligns with the notion that Oumuamua accomplished its purpose and moved on. Oumuamua stands out from familiar space objects, suggesting there might be aspects of its nature that we have yet to comprehend. Validating or debunking this story is challenging because Oumuamua's unique characteristics pose difficulties for us to conclusively prove or disprove this intriguing idea, given the limitations of our tools and observations. But why is the careful study of Oumuamua considered challenging? Challenges and strategies in Oumuamua exploration. Studying Oumuamua thoroughly is quite a tough task that needs careful planning and execution. If scientists want to send a spacecraft to study this mysterious object, they have to create and launch it by the year 2028. This spacecraft must be specifically designed to withstand the harsh conditions of interstellar space, and equipped with advanced instruments to carefully examine Oumuamua's composition, shape, and behavior. Once in space, the spacecraft would need to perform complex maneuvers to reach Oumuamua, and one suggested approach involves using Jupiter's gravity to propel the spacecraft forward, significantly reducing the travel time. The estimated journey for the spacecraft to meet Oumuamua is around 26 years, depending on its speed and trajectory. Alternatively, scientists have suggested a different route that utilizes the gravitational forces of Venus, Earth, and Jupiter. By carefully aligning the spacecraft's path with these celestial bodies, it becomes feasible to reach Oumuamua within a similar time frame while minimizing the risks associated with proximity to the Sun during the journey. Throughout its mission, the spacecraft would spend about 4 years harnessing gravity assists from Earth, Venus, and Jupiter. These assists act as momentum boosters, facilitating trajectory adjustments and ensuring precise navigation, intending to meet Oumuamua between 2050 and 2054. Upon reaching Oumuamua, the spacecraft would enter a crucial phase of scientific investigation. Equipped with advanced instruments, it would thoroughly examine the object's composition, unveiling valuable insights into its makeup, origin, and inherent characteristics. Detailed observations of Oumuamua's shape and behavioral patterns will be conducted, aiming to unravel its mysteries and gather essential data. Communication presents a substantial hurdle for the mission, given that Oumuamua is quite far from Earth. To communicate with the spacecraft, an advanced communication system is needed, possibly using cutting-edge technologies or a network of relay stations to cover the vast interstellar distance. Communication presents a substantial hurdle for the mission, given that Oumuamua is quite far from Earth. To communicate with the spacecraft, an advanced communication system is needed, possibly using cutting-edge technologies or a network of relay stations to cover the vast interstellar distance. One feasible choice is to utilize NASA's Deep Space Network, which has specialized antennas for long-range communication. The DSN's powerful transmitters and sensitive receivers would capture signals from the spacecraft and send important information back to Earth. In addition to traditional radio wave communication, exploring alternatives like laser communication systems is an interesting option. Using focused laser beams could greatly improve data transmission rates compared to radio waves. In the future, one very good idea is to create an interstellar internet. This would be like a network of relay stations in space that send data from spaceships to Earth. Just like how information travels between points on the internet, this interstellar network would need really advanced technology and structures for communication. Dealing with the big distances in space would mean that spaceships must have very good transmitters and receivers. These systems would use the latest methods to send and receive data effectively while minimizing any loss of signal quality. Another way to communicate during a mission to study Oumuamua could involve working together with projects like Elon Musk's Starlink. Starlink is trying to make a huge network of satellites in space that gives internet access everywhere on Earth. Using the Starlink satellite network could make communication better for faraway space missions. Outfitting the spacecraft assigned to investigate Oumuamua with a communication system that works with Starlink's network could allow sending data back to Earth. This could broaden coverage and increase data transfer speeds, which would be advantageous for studying and analyzing Oumuamua scientifically. However, making this collaboration happen would need careful planning and cooperation among space agencies, private companies like SpaceX, and the scientific community. Technical aspects like making sure communication protocols match, adapting spacecraft equipment, and synchronizing orbits would need careful consideration. Since NASA is already working with SpaceX, extending this collaboration to scientific research might be a challenging but achievable step. Even if we solve the communication problem, there are still many other important things to think about. Engineering a mission to unravel Oumuamua's secrets. Planning a mission to study Oumuamua involves a lot of complex tasks like designing the spacecraft, figuring out how it will move, navigating in space, collecting data, and analyzing it. These challenges show that these missions have many different aspects that need careful planning, thorough testing, and creative solutions. Dealing with these difficulties means bringing together different experts, using new technology, and working together with different groups. As we try to learn more about faraway objects like Oumuamua, each step we take forward requires careful planning, strong dedication, and a readiness to explore beyond what we currently understand about the universe. Exploring a special space object like Oumuamua provides an incredible opportunity for scientific discovery. However, it's a complex challenge. There are many technical problems that need creative solutions. Interstellar objects like Oumuamua require high-quality tools that can withstand the tough conditions of space. Engineers and scientists have to create advanced equipment that works perfectly in the extremely cold and radiation-filled environment of interstellar space. This requires not only new ideas, but also thorough testing to make sure the spacecraft and its instruments will work reliably. Going into unknown territory comes with risks. We still don't know exactly what Oumuamua is made of or what it's like. This uncertainty means there could be unexpected problems during the mission. From dealing with dangerous substances to facing high radiation levels and the potential impact of tiny meteoroids, scientists and engineers have to carefully analyze these risks. They need to create strong plans to protect the spacecraft and ensure the mission stays safe. Steering and controlling the spacecraft to reach Oumuamua is no easy task either. It requires very careful navigation and complicated maneuvers. Matching Oumuamua's path and making necessary adjustments needs extreme precision. Even a small mistake could mean missing opportunities or facing the risk of collision. The key is in accurate trajectory calculations and reliable propulsion systems, which are crucial for a successful mission. Despite our preference to avoid thinking about it, the availability of resources is a big factor. Launching a mission of this size requires a lot of money and the latest technology. Securing enough money and support from space agencies and governments, especially with many other priorities in space exploration, is a tough challenge. Overcoming these obstacles requires careful planning, forming partnerships, and making sure everyone involved works together effectively. This is not an easy task, especially with the many demands on Earth competing for the same funds. But this doesn't mean we have to give up on learning more about this interesting object. There are things we can do right now on Earth. One option is to use telescopes and instruments to observe Oumuamua. Even though it was visible for only a short time, astronomers were able to gather important data when it passed through our solar system. The initial observations provided some valuable insights. Now, with all the recorded information accessible, scientists from around the world can work together to discover more data. They can combine their expertise to explore deeper and uncover additional insights from the existing information. By making the most of the data already available and collaborating, scientists have a chance to uncover more mysteries about Oumuamua without necessarily taking on the difficult task of an interstellar mission. This approach optimizes our current resources and knowledge to enhance our understanding of this mysterious visitor from beyond our solar system. Determining the path Oumuamua follows has been crucial in figuring out where it came from and where it might be headed. By calculating its route, scientists have gained insight into the object's journey between stars, shedding light on the part of space it probably came from. Even if more direct information about Oumuamua is hard to come by, these orbit calculations significantly help us understand how interstellar objects move and interact within our solar system, an accomplishment on its own. The use of computer simulations is fundamental in Oumuamua's study. Scientists create virtual models based on available data, enabling them to explore different situations and test hypotheses about the object's composition, behavior, and likely origins. These computer simulations are really important. They help us better understand Oumuamua by refining our knowledge of its properties and giving us insights into the complicated processes that control its journey through space. Scientists are also looking at the chemicals in Oumuamua to learn more. They study its colors and do chemical tests to figure out what elements it's made of. This kind of examination can reveal important information about how Oumuamua formed and what it's like. Recent research suggests that Oumuamua might come from a comet made mostly of nitrogen ice. This shows how chemical analysis is crucial for solving the mysteries of Oumuamua. But what does the future hold for the study of Oumuamua? Telescopes unite to decipher Oumuamua's secrets. You see, comparing Oumuamua to things we know about in our solar system and beyond is helpful too. Scientists can see what's similar and what's different, which gives us a better understanding of Oumuamua's unique qualities. This approach helps us learn more about the diversity and nature of objects in space. Looking ahead, there are big opportunities to study more interstellar objects. Future projects like the Large Synoptic Survey Telescope and the Vera C. Rubin Observatory are ready to change how we find and learn about these cosmic travelers. The LSST is set to make a groundbreaking discovery. It is estimated to find more than 100 interstellar objects larger than 2 meters each year. This influx of new objects will give us many fresh targets to study in detail. significantly advancing our knowledge in this area. The Vera C. Rubin Observatory, known for its thorough and systematic surveys of the sky, will play a crucial role in expanding our understanding of cosmic phenomena, including interstellar visitors. Its comprehensive approach fits well with the study of objects like Oumuamua. While the PanStars One Telescope already contributes significantly to this field, the combined efforts and additional resources from upcoming observatories like LSST and the Vera C. Rubin Observatory are expected to greatly enhance our exploration of interstellar objects. The Hubble Space Telescope is a really important space tool that both NASA and ESA use. It takes very clear pictures, and these have been important in studying Oumuamua. The detailed images from Hubble have given us important information about what Oumuamua looks like, its surface, and its color. This information is very important and could help us figure out more about this mysterious visitor from space. Another telescope called the Very Large Telescope in Chile, run by the European Southern Observatory, has also been a big help. It has fancy tools like the focal reducer and low dispersion spectrograph that have helped analyze the light from Oumuamua. This has given us more insights into what Oumuamua is made of and possibly revealed some special features. Working together, the Atacama Large Millimeter Submillimeter Array in Chile has added to our understanding by looking at Oumuamua using longer wavelengths. ALMA's radio telescopes have given us valuable information, like hints about possible gas emissions from the object, providing more clues about what it's like. While Oumuamua was moving through our solar system, the James Webb Space Telescope shows great promise for future studies of this space traveler. But can the JWST see Oumuamua for now? Unfortunately, Webb can't capture images of Oumuamua because it's too dim for the telescope. As of now, Oumuamua has a brightness of about magnitude 37, which is extremely faint. To put it into perspective, objects with a magnitude of 5 can be seen with the naked eye, and most telescopes can handle up to magnitude 12 or 15. Webb, being a powerful space telescope, can see up to magnitude 34, but Oumuamua is still too faint for it. Despite this limitation, we know Oumuamua's location and trajectory. In theory, we could send a spacecraft to intercept it within the next 10 years. Webb can see objects as faint as magnitude 34, but Oumuamua remains elusive. Scientists have a plan for future interstellar objects. In 2028, a new spacecraft called the Comet Interceptor will be launched. It will hang out at the Lagrangian point, waiting for the next interstellar object or a long-period comet to pass through the solar system. When that happens, the spacecraft will intercept it, capturing images as it goes by. Rather than chasing down an object already leaving the solar system, scientists are opting to wait for the next opportunity. The upcoming Comet Interceptor mission, set to launch in 2028, will be ready to capture images of the next interstellar object or long-period comet. This strategy involves using simpler spacecraft, like the Interceptor, instead of designing gigantic ones specifically for known objects. The hope is that with observatories like the Vera Rubin Observatory, cataloging everything in the solar system, we'll be able to identify and study more interstellar objects in the future. This approach won't answer the question of whether Oumuamua is an alien spacecraft, but it aims to gather more information about these celestial objects passing through our solar system. Thank you for watching. Don't forget to show your support. Hit the like button, share your thoughts in the comments, and subscribe for more awesome content.